work part of the way through problem number 11 in surface integrals. Just set it up and maybe talk a little bit about the problem. I think one of the things I have difficulty with surface integrals is there's so many moving parts to it, and keeping them straight can be difficult, and what all of the parts mean. So in problem number 11, they give us a surface, and they tell us the surface is 2x plus 3y plus 6z is equal to 12. And we're only interested in the first octet. So if I think about this, I'm looking at a plane that goes through 6 on the x-axis, 2 on the y-axis, and 4 on the y-axis, and 2 on the z-axis. So here's my sketch of the plane. So this is the surface I'm going to be integrating a function over, and the function that I'm interested in is a mass function. So what are the purposes of doing something like a surface integral? One of the applications might be to find the mass of a lamina given the function. The mass is a function of the position of the position on the surface, and they tell us that the mass is equal to x squared plus y squared. So that's going to make life a little bit easier. We don't have any z involved in here. So my z, I'm going to have to rewrite my surface in terms of z is equal to, and I get 2 minus 1/3 x minus 1/2 y. I believe that's right. Yes. Okay, and so now I'm pretty much ready to set this up. I might as well do one more thing. I'm going to need the partial derivatives of z, gx, y, and the partial with respect to x is going to be negative 1/3, and the partial with respect to y is going to be negative 1/2. And now I'm ready to fill everything in here. I'm looking at the double integral of the mass function x squared plus y squared times g with respect to x squared plus g with respect to y, the partial squared plus 1. So this looks a lot like what we're doing when we're finding the surface area of something. And I'm doing this surface over some area. Okay, so now I could fill in my information. I know that if I fill this in, I get, so okay, I'll write my integrals here, x squared plus y squared, and this is going to be the square root of 1/3, 1/9 plus 1/4 plus 1. And I'm going to do this with respect to y and then with respect to x. So now let me fill in my limits of integration. Coming back to my picture here, I could write this as a function of x or a function of y, and since I'm going to do my dy first, I'm going to do this in terms of x. So y is equal to, let me figure this out here, y is equal to 2 minus 2/3 x. So with respect to the xy plane, I'm going to be going from 0 to 2 minus 2/3 x. And then with respect to x, I'm going from 0 to, where did I say it came out to 6 on the x-axis. So there's my integral. I might as well simplify things a little bit. This comes out to be 7/6. Now I'm going to do my double integral over the area in the plane, which is based on the surface, or written in terms of the surface, I should say. And I'm finished. Now I have my integral of a function over a surface defined by the areas in the plane. And doing the algebra here. You know, in a lot of ways, if you can get these integrals set up, the rest of it should either be something you can crank out or something that you can put in a double integral calculator. But let's look at, before I just sign off, let's look at what we really did here. We had a surface. In this case, the surface is a plane, so that's easy to work with. I rewrote the surface in terms of z. I'm going to need that when I find my partial of x and partial of y for this part of the formula. I'm told where I want it, what area in the xy plane I want this to be over. I want it over the first octant, so I wrote the bounds of this plane that I'm interested in terms of x and y. And then I'm taking the integral of the function over this area. Okay? So that's really all there is. We've gone ahead now, and we're no longer just looking at the area in a plane, nor are we looking at, let me do it this way, the volume over an area in the plane, nor are we looking at a line integral. We're integrating a surface over a path. Now we're actually going ahead and we're saying, let's take a surface, and in this case, nice easy surface, a plane. I wish they were all planes, and I'm going to take this function, which in this particular case happens to be a mass function, and integrate it over the plane. Okay, here's the integral. See if you could set it up on your own, see if it makes sense, see if you agree with me, and see if you could solve it. Best of luck to you.